Okay, so we left off in the middle of 8.3 talking about how to write complex numbers in trig form. So remember, trig form looks just like what's in that box. That's a final answer in trig form. To write something in trig form, you need two things. You need a radius, which is the distance. Let's basically think of it as the distance that that point is from the origin on a circle. So it's a distance. And then you need an angle, which is the amount of rotation to get up to that point. Okay, starting from the positive x-axis right there. So if you made a triangle out of it, that's the angle that you're looking for right there. Right? And the radius is really the what of that triangle? Yep.
Square root of x squared plus y squared.
Okay, so that's how you find it. And what? So what's the name of the radius in the triangle? Yeah.
R.
It's the hypotenuse. Yeah. So that's the hypotenuse. So let's try one more. Okay. Remember, when you are finding the angle, there's a little bit different formula depending on if you're in quadrants 1 and 4, which inverse tangent works naturally for. And then in quadrants 2 and 3, it doesn't work unless you adjust it. And the adjustment is to add pi or 180. I always do it in degrees first, and then I'll change to radians. And that has to do with if I'm going to get a nice answer. I know it'll come out nice in degrees. OK, so let's try one more. Find the trig form. We'll just call this example 3b. We did one, that's quadrant 2. Let's do a different quadrant. Let's do 3 plus 4i. Okay. That's not trig form. Does anyone remember what we call that one?
Standard.
That's standard, yep. That's standard form. Standard form tells you left and right movement, and then up and down movement. So it's right 3, up 4, and you're making a triangle. All right. What are the two letters that I need if I want to write this in trig form? What's one of them? Yeah. Yep, I need theta. And can someone else give me the other letter I need? Oh, I need r. Okay, to find r, you can graph the point 3, 4, and then use the Pythagorean theorem to find the distance from that point to the origin. Okay, remember, that's like the radius if you were to make a circle. That's what we're talking about. Okay. What's the radius going to be in this case if you use Pythagorean theorem on the 3 and the 4?
5.
Yeah. 5. You're going to get a nice answer for the radius. Okay. If the radius comes out to a number that you can reduce, like square root of 12, you would want to write that as like, what would that be, 2 root 3. Okay. But this time it reduces nicely. Okay, so we got that. Now we need to find this angle right here. We are in quadrant 1. Can someone remind me, what's the formula for theta when you are in quadrant 1? Yep. Jeff?
Theta is your reference angle.
Yep, and what's the formula you use to find that? Moises, can you help him out? Yep, inverse tangent, y over x, right? This is not the one where you need to add the 180 or the pi, okay? It's just, you just do the inverse tangent of y over x. That's your x, that's your y, okay? All right. Now, a 3, 4, 5 right triangle The angles don't come out nice. So you could do it in radians or degrees. You just have to read the directions. But no matter what you do, it doesn't come out nice. I'll do it in degrees. So inverse tangent of y is 4, x is 3. So we're going to get an angle of 36.8. We'll just say 87. Okay, 36.87. Now to write it in trig form, put it in that r cosine theta, I sine theta. So r cosine theta plus I sine theta. That is your final answer. If you do that out, if you take the cosine of 36.87, multiply it by 5, you will get 3. If you take the sine of 36.87 and distribute the 5 to it, you will get 4. That would be changing it back. We don't want to change it back. Okay, you could check it that way if you wanted, but that's your final answer. Okay. Any question on that? Okay, so what's the point of writing it that way? Well, it's going to make certain things that we want to do, specifically multiplication, division, raising to a power, and taking a root very well. It'll make the first 3 very fast. So the first, we're going to look at the first 2, multiplying and dividing complex numbers. I'll review quickly how we've done it before, but I want to get away from the way we used to do it because it's a lot more work to do it this way. All right? So let's look at the old way first. Does anybody remember what you have to multiply top and bottom by if you want to divide by 5 plus I? Yep.
The conjugate.
The conjugate. So you got to remember that, and then you got to remember what the conjugate is, which in this case, yeah.
5 minus I.
Okay, 5 minus I. Now this isn't even as bad as it could be because the top, it's not a double distributive, it's just a single distributive. Right? So it's just 15 minus 3i. But that could have been a double distributive, which would have taken a little longer. Okay. Now at the bottom, I'm going to do that out. 5 times 5 gives me how much? Clover? 25. And then 5 times negative I, 5 times positive I. What's going to happen there? They cancel, so we don't have to worry about that. What's I times negative I?
I squared.
Nope, not I squared.
Negative I squared.
Negative I squared. And I want to go one more step with that. What's negative I
1.
squared? What is it?
1.
1, yes. So now when we write that in standard form, it's 15 over 26 minus 3 over 26 I. Okay? So there's a lot of things we have to remember there when we divide complex numbers using standard form. Now we're going to get away from standard form. We're going to use trig form. I would say trig form is only worth doing if the problem was already given to you in trig form. If the problem was given to you in standard form, it's probably quicker to do it this way. It's going to take longer for me to change this to trig form, change that to trig form, and then do what I'm about to teach you. Okay? But if it's already in trig form, that's going to be really nice because we're going to have a very fast way to do all of this. Okay. So let's say that we had 2 complex numbers in trig form. Okay. They each have their own radius, calling them R1 and R2, and they each have their own angle, theta 1 and theta 2. So like in the problem we just did a minute ago, r would be 5 and theta would be 36.87. You're either going to be given something like that, or you would have to find it if they don't give it to you. In order to multiply, we'll start with multiply and then we'll do divide. In order to multiply two complex numbers, okay, the old way we had to do it was to distribute. Right? So you'd have something like 3 plus 2i, 8 minus 6i, and then you have to distribute everything out. That's going to result in having to combine like terms. Then you're going to have to change I squareds to -1, and you're going to have more like terms. So it's a few steps there. Well, if we had both of these numbers in trig form, all we have to do to multiply them together is two things. Take the two numbers in front and multiply them. Take the two angles right there and right there and add them. So it takes a process that had a lot more steps in it, a lot of foiling, combining like terms, and it reduces it to 2 steps. Multiply the radii, add the angles, and put the result right there. And that's it. Now division, it saves us even more time, because with division, not only do you have to multiply by the conjugate, but then you've got even more simplifying to do, because a division problem has a top and a bottom. So it's like you have 2 things to do. If we had complex numbers in trig form, anybody have a thought what we would do to get our new radius somehow involving R1 and R2? Yep.
Oh, involving R1 and R2.
Yep.
I think it would be like R1 over R2.
Yeah, we do R1 over R2. And how do you think we would get our angle when we're dividing? Yep.
Cosine 1 or cosine theta 1 over cosine theta 2.
So cosine's good. We're definitely going to have that.
Cosine theta 1 over theta 2.
Minus.
Yeah. Because we had a plus when we did multiplication. We're going to have a minus when we do division. So by dividing your 2 radii and subtracting your angles, that's going to eliminate having to multiply by the conjugate, then FOIL it out, combine like terms, change I squared to -1. That's all going to go away. And it's going to be replaced with this. And normally what I do is I do it in standard form, and then I do it this way and show you it comes out the same. I don't know if we're going to have enough time to do the same problem 2 ways to show you, but this does work. It is important that R2 is not 0, because you can never divide by 0. So if I ask you to divide 2 complex numbers in trig form, R2 will never be 0. Questions on those 2 formulas? All right, you know what? Since we already have one where we've already done it in standard form, so maybe we'll just take this problem, because it's already half done, and we'll do it again in trig form. And then once we get our answer in trig form, I'll convert it, and I'll show you that it comes out the same as that. Let's just make sure we did everything right on this one. I think everything looks good there. Okay. We're going to get decimals, so we're going to have to change those to decimals if we want to compare the 2 answers to see that they come out the same. So let's do 15 over 26 and 3 over 26. I'm just going to put those decimals off to the side. So we'll just keep those there. So 0.57 and 0.115. Okay. Yep.
I think back in the original example, 3 plus 4i, for inverse tangent, we had some lines in the y over x.
Not this one though.
No, not that one.
Oh, let's see. We did inverse tangent. Let's go back. It should be inverse tangent of y over x. So it should have been 4/3. Did I still have the calculation? Oh yeah, I did 3/4. You're right. So yeah, it should be inverse tangent of y. This is correct over here. It's y over x. 4/3. Thank you. Yeah, that makes a difference.
I was looking at on my calculator, I was like, that is only nice.
Yeah, so what we did is, by switching it, we found this angle up here. We want that angle down there. So we had the angle at the top, but we needed the one at the bottom. So it's 53.13. Thank you.
So, I thought I was going crazy for a minute.
Nope. So you cannot switch the y and the x. If you do, you will get the wrong answer. You'll actually get the complement. You'll get 90 minus your answer. That's not what we want. Okay, so now let's try to do this problem in trig form. So the first thing we need to do if it's going to be in trig form is we need both of these numbers changed to trig form. Okay. Kind of like we did in this problem right here, except no mistakes this time. All right. Let's start with 3. What's the imaginary part for 3? Yeah?
There is one.
There isn't. So let's just put 0i. So let's think about what r and theta would be. You've gone right 3. How far are you from the origin if you go right 3? You don't need Pythagorean theorem this time to figure that out. Yeah? 3. So your radius is 3. And because you're on an axis, you don't need inverse tangent y over x. We don't use that. What's your angle when you are right there? Yep. 0. Okay. So there's my r and my theta for my first one. Now 5 plus I, that one's not as nice. So we are right 5, up 1. 5, 1. My radius is going to be the square root of what, using Pythagorean theorem?
5 plus 4, 5 squared.
26. And my angle, what quadrant? Waylon, what quadrant am I in? And what's my formula for theta in quadrant 1? Yeah. Inverse tangent. Inverse tangent of y over x. Y is 1, x is 5, if you trust me. Inverse tangent y over x. We got it right this time. Okay, so now let's get that angle. That's going to be the only thing we have to round, but I do want to round it. So it's 11.3, pretty close to 11.31. Okay. So think of this as your R1. Think of that as your R2. Think of that as theta 1. Think of that as theta 2. I want to divide it. I want to divide this one by that one. what do we do with the two radii when we are dividing two complex numbers in trig form? Take the radii and, yep.
R1 over R. The first term is R3.
So R1 over
R2.
over R2. That's the new radius of the final answer. Cosine. And how do we get our new angle for the final answer? Yep.
We take the new, or we take the old one and subtract it with the new one. Theta 1 minus theta 2.
So theta 1 minus theta 2. Okay? Whichever one is in the top, that's the one that we're calling like theta 1, and the one that's in the bottom we're calling theta 2. So it's 0 minus 11.31, which is negative 11.31. Now, if they said to leave the answer in trig form, that is one way we could leave it. I want to convert that back to standard form to see if it really comes out to 15 over 26 minus 3 over 26, or roughly these decimals. But leaving it in trig form with a negative angle, they may not want you to do that. What's one way you can take an angle that's negative and make it positive? Yep.
Add 180.
Can't add 180 to sine or cosine because that's not the period length. With tangent, you could add 180.
Add 360.
We have to add 360. Okay? So that is one way, if they do say to leave your answer in trig form, but not as a negative number, you could write your angle as 348.69. Okay, and there is one other way you can get rid of the negative. We talked about this when we did identities. When you have a negative in a cosine function, the negative doesn't make a difference because the negative is symmetrical over the y-axis. But the cosine function has symmetry over the y-axis. So flipping it horizontally, which is what that negative would do, wouldn't cause anything to happen. So when you have a negative in a cosine, you can just get rid of it. When you have a negative in a sine, you cannot. But does anybody remember what you can do with the negative? Where can that negative go? Yep.
The outside.
It can go on the outside in front. Okay, so that's all identities we've talked about. Any one of these answers, they're all the same. It's just the bottom two, I got rid of the negative inside. All right, now let's just take one of them, distribute this out, and see if we get 0.5769. Okay, well, for the first part. If we do, then we know what we did in trig form is the same as what we did in standard form. So let's see. So we have 3 divided by square root 26. I'm not worried about fixing the square root in the bottom right now. Should I? Yes. Is that the goal of what we're learning right now? No. Okay. So 3 over the square root of 26 times the cosine of negative 11.31. And if it's equivalent, we're hoping to get 0.5769. Yep. So what we did in trig form was exactly the same as standard form for the real part. Now let's do the imaginary. So we got 3 over root 26 times sine of negative 11.31. Okay. If what we did here is correct, it should match the imaginary part of 0.11538. Negative
It's a
0.11.
negative. The sign it has a negative in it.
Oh, did I just not copy down the negative? It's negative 0.11538. Oh, yeah. Negative. So we're good. Yep. So I'm just trying to show you what we did in standard form and what we just did in trig form result in the exact same answer. All right, so that's multiplying. Let's try, that's dividing. Let's try one with multiplying. Okay, this time I'm going to give you two numbers to work with. I've already changed them to trig form for you. Okay, so changing them to trig form, that's probably the longest part of the whole problem. And what I want to do now is multiply these two numbers together. Okay, and let's leave our final answer in trig form. So I'm not going to convert it back to standard form. All right. So if I want to multiply these two complex numbers together, what would I do with my radii? Yep.
Multiply them.
Multiply them. Dex, what's my first radii?
5.
5. And my second one?
2. Or 2 root 2.
2 root 2. So if we multiply 5 times 2 root 2, that's 10 root 2. And that is a proper answer. There's no square root in the bottom, so you could leave that as a final answer. You're good. Okay, so that's your radius. Now we need our angle. Okay, my first angle is 0.93, and that's radians because there's no degree on it. But it's fine. It doesn't matter if you do radians or degrees. We just have to know what to do with the two angles when we multiply. So what am I going to do with theta 1 and theta 2? Yep. You're going to add them. Yep. So 0.93 plus 2.36, 3.29. And that's it. So multiplying them together by adding the angles and multiplying the radii, that takes the place of everything you would have done in standard form. You don't have to worry about distributing, combining like terms, or changing I squared to -1. That all goes away. But you have to understand how to write this in trig form. That's the trade-off. Okay, and division, I'm not going to do this division problem because I did a different division problem with you already. If you were going to do division, what would you do with your two radii? Yeah? Divide them. And what would you do with your two angles? Yeah? Subtract them. Okay, remember, when you subtract them, that could result in a negative number. Okay? If you get a negative number, there's different ways you can deal with it. So I tried to show you 3 different ways that you could deal with a negative number. Adding a multiple of the period, whether it's 2 pi or 360, or just getting rid of the negative with cosine and moving it in front for the sign. Hey, what's going on here? Sure, no problem. You're welcome. Okay, and that was really it for that section. Okay, so put that up, give people a minute to copy that down. That'll be tonight's homework. And then at the end of the video, I'll put that up again with tomorrow night's homework. All right, so the last section we're going to look at is 8.4. And 8.4 is very much connected to 8.3. Instead of taking two complex numbers in trig form and multiplying and dividing them, we're going to take two complex numbers in trig form and raise them to a power. And the opposite of raising to a power is taking a root. So we're not going to go through the full proof of how you raise a number to a power, but I will show you like an example in standard form. If you wanted to raise this to the 5th power, it's going to take a while to do that up, because you need to do 3 plus 2i times itself 5 times. I mean, it's doable. It's just it's going to take a while to FOIL all that out. Right? And I guess you could use some shortcuts, like once you FOIL these two together, you're going to get the same result when you FOIL these two together, so you don't have to repeat that. You can just copy your answer from the first one. But then you're going to have to FOIL more to get to the final answer. Okay? So that's not ideal. And even worse, like, what if it said to the 58th power? Well, now, I mean, even with shortcuts, if you try to do 3 plus 2i 58 times, there's hundreds of multiplication steps, right? Hundreds of combining like terms. It's just not, it's not really doable that way. So with what's called de Moivre's theorem, that theorem doesn't care if the exponent is a 5, a 58, or a 5008. You can do either problem in the same amount of time. So let me show you. I'm going to show you without going through the whole result and see if you can recognize the pattern. With de Moivre's theorem, if you wanted to take that complex number and square it, this would be the answer. So I did something there. And then if I wanted to take that and cube it, right, the original, and cube it, I would have this. So cubing it, I mean, that's not too bad, but that's still, cubing involves 3 sets of parentheses, having to FOIL, and you probably have a dozen or so combining like terms and multiplications to do up. But this is a lot faster. So does anybody see the pattern in this formula, just based off looking at how you would square something and cube something? So like, what do you do to the radius, and what do you do to the angle? Yep. Yeah. So with de Moivre's theorem, first of all, this only works if you're raising to an integer power. So if you want to raise something to like the 3.2 power, well, we're not really getting into that. But if you're raising something to a non-decimal integer power, all you have to do is raise the radius to the power and multiply the angle by the power. That's how you raise something using de Moivre's theorem to a power. Okay, you raise your radius to the power, and you multiply your angle by the power. Now, when you multiply the angle by the power, these two together, that can get pretty big. Right? If your angle was originally like 50 degrees, and you're raising that to the 10th power, you're going to end up with 50 times 10. Right? When we get an angle that's bigger than 360, it's kind of like getting a negative angle. We don't want to leave an answer bigger than 360 here. So what we'll usually do is subtract 360 to make it smaller. But that's called de Moivre's theorem. So let's try that on this one. All right. In order to use de Moivre's theorem, the problem has to be set up a certain way. It has to be set up like this. What what format do we call that? Yep, that's trig form. What format did they give me here? Yep, standard. So I can't do de Moivre's theorem with that. So first thing I need to do is change that to trig form. Right? Now, is it worth changing it to trig form? Yes, I would say that's definitely going to save you time, especially as this exponent gets higher and higher. Could you do out to the third power by hand? Sure, it's not that bad. But if it was like a 30th power, you don't want to be doing that by hand. Okay. So let's figure out r and theta. Okay, so we've got a real of 1 and an imaginary of root 3. So that's right 1 up about 1.7. Okay. What's my radius going to be if my side lengths are 1 and square root 3? Yep. Let's see. So we square that, we get 3. Square that, we get 1. 3 plus 1 is 4. Square root of 4, 2. Yep. So that's my radius. And I'm in quadrant 1. What's my angle? What's my formula for the angle in quadrant 1? Yep.
Inverse tangent of y over x.
Inverse tangent of y over x. So it's just the inverse tangent of root 3. Okay, so inverse tangent of root 3 gives me 60 degrees. All right. So now I've got a nice radius and angle to work with. It's going to be much nicer numbers than if I had tried working with that square root of 3 and foiling. And I've got r cosine 60 plus I sine 60. And we're going to take that and we're going to cube it. Okay. What's going to be the calculation for my radius when I cube the original problem? How do I get my radius? Yep.
Radius cubed.
So I'll take my radius and cube it. Yep. And how am I going to get my new angle? Yep.
Then is it 3 times 60?
Yep. 3 times 60. I'll just put that for now. 3 times 60. 3
That's actually a
times.
really cool way to simplify the whole equation.
Yeah, it's a lot easier than having to do the distributive property. Yep.
Yeah.
So 2 cubed is 8. Cosine 180 plus I sine 180. And that is your final answer in trig form. If they wanted the final answer in standard form, well, then you just distribute out what you have. Do 8 times cosine 180. That gives you negative 8. So negative 8. And then do 8 times sine of 180. 8 sine 180 gives me 0. Standard form. So when you cube that, you get that, negative 8. Now, what's the opposite of cubing? Yeah.
Cube root.
Cube root. So if you cube root negative 8, you should get that if you went backwards. You'd get that, and you'd get 2 other answers. Okay? When you take a root, there's always as many answers as the index. So if you're doing cube root, there's 3 answers. If you're doing 5th root, there's 5. Square root, 2. Okay. We hadn't talked about how to do that root, like how would you go backwards and get that? We don't know that yet, but I'm going to show you. All right, let's try this one. Okay, this is to the 8th power. You definitely don't want to be writing that out 8 times and trying to distribute it. So we have to change to trig form. And what are the 2 things that we need in trig form? Yep.
Radius
Radius
and theta.
and theta. Okay. Draw this out. We've got a negative root 2 over 2, positive root 2 over 2. So we're somewhere right about there. 2 over 2, 2 over 2. Okay. We do Pythagorean theorem on that. What's root 2 over 2 squared?
1/2.
1/2. Because if you square the top, you get 2. If you square the bottom, you get 4. 2/4 is a half. So if you square that, you get a half. What if you square that?
1/2.
A half. Add them up and take the square root.
Square root of 1.
So what's your radius?
Square root of 1.
Which is
1.
1. Radius is 1. And now to find your angle, you'd be doing inverse tangent of y over x. If you divide y by x, what would you get? Yeah,
Negative 1.
-1. Now, because this is in quadrant 2, what are we supposed to add onto the inverse tangent? Yeah? If you wanted to do degrees or radians, you could do plus pi. And what if we want to do degrees?
180.
Let's add the 180. Okay. You can check that on your calculator, but if you do that out, inverse tangent of -1 is -45. That's 135. Okay. There's my angle. There's my radius. And we're raising that to the 8th power. Okay. How am I going to get my new radius? Yep.
Radius to the 8th power.
Right. I'm going to take my radius and I'm going to raise it to the 8th power. What's 1 to the 8th power? 1. So it's 1 cosine something, I sine something. And how am I going to get my new angle? The angle in the original problem is 135. That's the angle on the circle going like that. Yep.
Multiply 135 by 8.
Okay, I'm going to multiply 135 times 8. Now that's a pretty big number, so we generally don't want to write it that big. So what could I do to make that angle smaller? Yeah.
Use the period of cosine, which is 360, and subtract it how many times?
Yeah. So we could minus 360. In fact, we can minus it 3 times, and we end up with an angle of 0. So a 1080 is just 3 revolutions. So it's the same as 0 degrees, 0 degrees. That would be your final answer in trig form. You could just write cosine 0 degrees plus I sine 0 degrees. You don't need to put times 1. Normally you do need to put the radius, but in this case it's just a 1. Any question on that? So that's all there is to raising a number to a power. Once you know your radius and your angle, just raise the radius to the power and multiply the angle by the power. Okay, so I already kind of asked you about that. In example 1, we took something and we cubed it. And then I asked you what would be the reverse. And the reverse is cube root. So in example 1, I think we got -8 as the final answer in standard form. So if you took the cube root of -8 to go back to the original problem, that would be one of the answers you get. That's one of the cube roots of -8. 1 plus root 3i. And if you're thinking, well, isn't the cube root of -8 -2? Yep, that's another one. Okay. When we're taking roots, we can have real answers, and we can also have imaginary. All right, so the last thing we'll look at is how do we take a root? So when we are doing a root problem, this is basically the kind of equation you're going to have to solve. You're going to be trying to solve for z. That's going to be what you want to know. And the only way to solve for z is to get rid of this power. In order to get rid of a power, you need to take a root. It's the only way to do it. One specific kind of problem that they are going to have you do, and this is just kind of a vocabulary thing, if they ever say find the roots of unity, it just means to find the roots of 1. So if I said, tell me the square roots of unity, the answers would be 1 and -1. It just means square roots of 1. I would tell you that if you forgot it on a test, but I don't want you to get confused by that word. Unity just means 1. They don't use any other special words for other numbers. They would just say, like, find the square roots of 2, or find the square roots of whatever number. I would say in general, we're probably not going to go much above like a third or a fourth root, because they start taking a long time. You're always going to have as many answers as the index. So like if I gave you a 12th root problem, you would have to find 12 answers. It's not hard, but it's going to take a while. It's very repetitive. So on the test, I would expect like a cube root or a 4th root problem, 3 or 4 answers. Okay, so I think rather than going through the description, I think it's going to be easier if I just go through a problem. Okay, and I'll add some notes in as we do it. So I want to find the 4th roots of unity. What that basically means is I want to solve this equation. So if I take the 4th root of each side, those are my answers. I just want you to figure out what those answers are. The problem with that is the calculator can't give you the imaginary answers. 1 and -1 are 2 answers. Right? But how are we going to get the imaginary ones? That's what I'm going to show you. Okay. So the first thing we have to do is we have to take our equation and we have to convert all of that into trig form. Okay. So that's the first step. The reason we're going to convert to trig form is because that makes it a lot easier to do some of the arithmetic. Okay, let's start with the right side. The right side doesn't have an imaginary part, so if you want to think of it as plus 0i, you can. Let's graph 1 plus 0i. Where is that point, 1 plus 0i? Yeah, it's 1 on the x-axis. What is your radius? Right there. 1. Okay, that's an easier one. And for your angle, you don't need to use inverse tangent because you're right on the axis. What's your angle in that case? 0. If you were not on the axis, you'd have to use inverse tangent and Pythagorean theorem to figure out your radius and your angle. But that's the right-hand side. 1 plus 0i is going to turn into r cosine theta plus I sine theta. Do you really need the 1 in the front? No, but if it's not a 1, you will need it. So I would put it. Okay. Any questions how I converted the right side into trig? Now I need to convert the left side. Problem is the left side is just a variable. I don't know what the radius is, and I don't know what the angle is. That's what I'm trying to find. So for z, we're just going to write that very generically. We don't know the r, and we don't know the theta. So we're just going to change z to some radius with some angle but I am raising it to the 4th power. Again, what's the radius and what's the angle for z? I don't know. So I can't fill in anything. That's always your first step for z. You just change it to r cosine theta, I sine theta. The other side, no, you don't do that generically. You'll have numbers here. You need to figure out the actual r and theta for the right side, okay, but not the left. Now, let's simplify the left. So simplify the left-hand side. If we use de Moivre's theorem, what would the left-hand side turn into? Yep.
R to the 4th cosine times
Cosine
or
of.
cosine of 4 theta plus I sine 4 theta.
Yep. That's all I'm going to do in that step. So I've done out the 4th power on the left. Keep the right exactly the same. Okay. So now we have something on the left, we have something on the right. What is my expression for the radius on the left side? Okay, you see it? What's my radius on the left side of that equation?
Radius to the 4th.
R to the 4th. Can someone else tell me what's my radius on the right side of the equation? Yep, just 1. The next thing we do is set the radius on the left equal to the radius on the right. So we have R to the 4th equals 1. Okay, I'll come back to that. What is my angle on the left? Yep, 4 theta. What is my angle on the right?
0.
0. So the next thing we do is set the angle on the left equal to the angle on the right. Angle on the left is 4 theta. Angle on the right is 0 degrees. This part is what's going to give us our multiple answers. Okay? We set the angle on the left to equal the angle on the right, plus what is the period of sine or cosine? We've added this onto the end of our answers before. It's like plus, we're going to put something on the end. And again, this isn't new. Yeah? 2 pi n, if we wanted to do radians. To keep the math easier, I'm going to stick with degrees for now. But yes, you could do plus 2 pi n, or in degrees.
360 degrees.
Yep. So you have to add that onto the end, just like we've done before, to get all of the answers. If you don't put plus 360n, you'll get one answer. Okay, but we want all answers. Okay. Now, let's solve each of those equations, and that's going to give me all 4 answers. Okay. How would you get r by itself in that equation?
Take the fourth root of both sides.
Yep. Take the 4th root of both sides. What's the 4th root of 1? Remember, this is a radius, so it's not imaginary. It's just a real number. Yeah.
The rate, wait, what was that?
4th root of 1 is 1. When we write down our 4 answers to this problem, because it's a 4th root, every answer is going to have a radius of 1. Okay. That's going to be my radius in all 4 answers. Okay. So for this one, we need to solve this for theta. How would I get rid of that 4? Yep.
Dividing both sides by 4.
Yep. Divide everything by 4. What's 0 divided by 4?
0.
So we don't need that part. What's 360n divided by 4?
90.
90n. We're doing a 4th root. So how many answers did I say you're going to have? 4. That means you need to let n equal 0, 1, 2, 3. That's how you get your 4 answers. So you let n start at 0, and you count up till you get as many answers as you need. This number always ends up being 1 less than the root. 0, 1, 2, 3. Yep.
Isn't it always n minus 1 for that kind of equation? Like it's
So I just start at 0. Like if I needed 5 answers, I would do 0, 1, 2, 3, 4.
yeah,
That would give me my
but
5
when you write it
answers.
out, like let's say 1, 2, 3, 4, 5, extending off to infinity, it's n minus 1.
Yep. Okay. So now all your answers, you write them as r cosine theta plus I sine theta. R cosine, what's 90 times 0? 0. There's your first answer. N equals 1. So radius stays the same. What's 90 times 1?
90.
90. That's your second answer. Third answer. Radius stays the same. This time the angle. What's 90 times 2? 180. And last answer. Radius stays the same again. Cosine. Oh, tell me. What's 90 times 3? Yeah. 270. Yep. And those are how you find your 4 answers. That's why if you had to do 12 answers, it just starts to get very repetitive. So these are the key steps right here in how you find roots. You've got to do it in trig form, simplify the left-hand side, and then set up these 2 equations. Radius left equals radius right. Angle left equals angle right. There's only one root problem on the test, and we can practice another one before the test. So this is tomorrow night's. I need Okay, so that's the homework for tomorrow night. It says something about graphing. Don't do any graphing. And I'll see you guys either tomorrow or on Thursday. We'll see about the assembly.